Okay, so the first thing I want to touch on, and the first thing that we did in class, is indices, exponentials, and powers. So before I look at indices, exponential powers as a concept, I want to first look at something more basic. You would have seen at some point in your education something like this, 2a, which is 2 lots of a. You should know when you have 2a, that is the same thing as 2 times a. 2 times a is 2 lots of a, which is the same thing as a plus a. Now this is an important concept because you'll see that multiplication is a shortened form of addition. So we can have, for example, 2 plus 2 plus 2. You're adding 3 2's together, so that is the same thing as 3 times 2. Okay, so again, multiplication is just a shortened way of writing addition. Now in the same kind of argument, we can have a shortened way of writing multiplication. So if you have the same thing multiplied together, so instead of 2 plus 2 plus 2, I can have 2 times 2 times 2. This can be written as 2 to the power of 3. So this is your indices, exponential, and powers. And all this is a shortened way of writing multiplication. Right, as a concept, from general principles, you have an indices, exponential, and powers will have two parts. First of all, it will have a base. So it will have a base, which is a big number. It will then have a power, which is a superscript. So the small number on bottom is called the base. This number on top is called your power, or your index, or your exponent. This is set as 3 to the power of 5, and what this means is you take the base 3, multiply by itself 5 times. So you take 3, multiply by itself 5 times, 3 times 3 times 3 times 3 times 3. So this is definition of your indices, exponential, and powers. Again, they are the same thing, just different names given by different people. We can then look at combining powers. So let's say you had a squared times a cubed. A squared is a times a. So this is my a squared times a cubed, which is a times a times a. So a times itself 3 times. So this part is my a cubed. And you will see altogether I have a total of 5 a's times together, which is the same thing as a to the power of 5. We can do very similar thing except with division. We can have a to the power of 5 divided by a squared. A to the power of 5 is a times itself 5 times. A times a times a times a times a. 1, 2, 3, 4, 5. Divided by a squared, which is a times itself twice. From your division, you'll see 1a cancels out 1a, 1a cancels out 1a, and you're left with 3a's, and this is just a cubed. The final thing we looked at was power to a power. So you can have a squared to the power of 3. So this is a power to another power. We look at the outside first, so we look at power of 3. This power of 3 means that you have a squared times itself 3 times. In other words, a squared times a squared times a squared. We can then expand this further. A squared is a times a, so a times itself twice, times a squared, which is a times a, times a squared, which is a times a. So this a squared becomes this a squared becomes this, and this a squared becomes this. And if you count the number of a's we have times together, you'll see we have a total of 6 a's, which is the same thing as 8 to the power of 6. So from here, we looked at the general rules for all numbers. If you times two indices of the same base, so going back to what we did here, if you times two indices of the same base, you'll find we are adding the number or the number on top or the power. Okay, so here a to the power of x times a to the power of y is the same thing as a of x plus y. So when we times the indices, we add the power. I'll write the example on the side here. A to the power of 3 times a to the power of 4 is simply a to the power of 3 plus 4, which is a to the power of 7. The next thing we did was division. So if you look, a to the power of 5 divided by a to the power of 2, you'll see we end up with 5 minus 2 gives us 3. So in this case, when we divide powers, so a to the power of x divided by a to the power of y, we are minusing the power. So when we divide indices of the same base, we minus the power x minus y. So if we have, the light just turned off, if we have a to the power of 6 divided by a to the power of 2, that is a to the power of 6 minus 2, which is a to the power of 4. The final thing we did up here is you have a power to a power, and you'll see your result is 2 times 3 gives us 6. In other words, if you have a power, a to the power of x, to another power, to the power of y, that is the same thing as a to the power of x times y. So when we have power to power, you times the power. An example would be a to the power of 4 to the power of 3 is a to the power of 4 times 3, which is a to the power of 12.